Question 4. In the diagram, A, B, C, D is a circle of center O. The quadrilateral O, B, C, D is a rhombus such that angle ADO is equal to angle OBA equal to Y, and angle BAD equal to T. Find A part of the question, the value of T. B part of the question, the value of Y. C part of the question, angle ADC. Before the solution, one approach I used in solving mathematics is that I ask myself certain questions and answer them. As I am doing that, I am equally solving the problem. Now, why is O, B, C, D a rhombus? It is so because it will enable us to find the value of T, because the opposite angles of a rhombus are equal. So if we get angle O and angle C both are equal, then we can find angle T, or the value of T. Now, this angle here is angle at center, which is twice angle at circumference. Then angle A and angle C, they add up to 180 degrees. That is opposite angles of a cyclic quadrilateral. With this, angle O and angle C are known. You equate them and find the value of T. We proceed with the solution. First, we need the obtuse angle BOD. We have two angles at the center. One is reflex, the other one is obtuse. So the obtuse angle BOD is equal to 2 times angle BAD. That is T here. You have the reason. So angle BOD is equal to 2T. Secondly, this angle here and this angle here, their sum is equal to 180 degrees. You have the reason. You replace angle BAD with T plus this angle equal to 180 degrees. You make this angle the subject by transferring T to the right hand side. It follows that angle BOD is equal to angle BCD. You have the reason. You replace the two angles. You have this linear equation. Collect like terms, add like terms. You have 3T equal to 180 degrees. Divide both sides by 3. T is equal to 60 degrees. B part of the question, we are to find the value of y. To do that, we have to consider triangle ABD. In that triangle, this angle is needed, this angle is needed. And again, we have to consider triangle BOD, which is isosceles triangle because the radii are equal. In that triangle, the base angles are equal. Previously, this angle is 2T and T is 60 degrees. Therefore, angle BOD is equal to 120 degrees. Let the base angles be equal to S. Now, in triangle BOD, you add the three angles and the sum is equal to 180 degrees. You replace the angles with what they stand for. S plus S is 2S. You transfer this angle to the right hand side. When you subtract, you have 30 degrees. To get S, divide both sides by 2. S is equal to 30 degrees. Now we cannot find the value of y by considering triangle ABD, where the sum of the three angles is equal to 180 degrees. Angle A is T, that is 60. Angle B is Y plus S. Now S is 30. You have it in this form, and this is angle D, equal to 180 degrees. You open the bracket, add like terms, transfer this value to the right hand side. You have it in this form. When you subtract, you have 60 degrees. Divide both sides by 2 to get y, and y is equal to 30 degrees. C part of the question, we are to find angle ADC. That is this entire angle. It is broken down into two angles in this form. Already we know angle ADO, which is y, to be 30 degrees. We get the other angle. Angle ODC is needed. In the rhombus, already angle BOD is 2T. T is 60, so that angle is 120 degrees. And because the two opposite angles are equal, this other angle BCD is also 120 degrees. These two other opposite angles are also equal. Okay, so you have it in this form. Angle OBC is equal to ODC. That is 60 degrees. 60 degrees. Sum of angles of a rhombus is 360 degrees. Now, if you add these two opposite angles, you have 240 degrees. The remaining two angles together become 120 degrees. If this angle and this angle, their sum is 240 degrees, and the entire angles here, their sum is 360. That means this angle and this angle together is 120 degrees, and because both are equal, each one of them will be 60 degrees. So this part is 60 degrees. You add it to angle y, this part of it, which is 30. Therefore, angle ADC is equal to 30 degrees plus 60 degrees, and that is 90 degrees.